Hello guys, welcome back to another video. In this tutorial, I will show you how to make this horror game using the brand new horror game template inside of Unreal Engine 5.6. We'll create and add this simple creature AI that chases the player around, and the goal of the game is you have to escape the level without getting caught to win the game. And if you guys enjoy this full tutorial on how to modify the brand new horror game template, be sure to check out some of my other tutorials that show you how to modify the other templates like the new first-person shooter game template. And if you are new here to the channel, my name is Smart Poly. I make all sorts of Unreal Engine news and tutorials, so don't forget to leave a like on the video and subscribe for more future content. And before we jump right in, I want to make a quick announcement about my Unreal Engine 5 multiplayer survival game course. I've just added the last few lectures to the remastered course, and if you guys want to learn how to make your own game inside of Unreal Engine, this is one of the best courses that you can take, as it shows you everything step by step, all the way from creating this entire game from scratch, creating systems like the drag and drop inventory system, gathering system, open world map, save and load system, and even how to set up the game for listen server, dedicated server, and single player. There's currently over 270 plus course lectures, and you get full access to the course on my website smartpoly.teachable.com for just a small purchase when compared to other Unreal Engine courses that charge an upwards of $300 to $1,000 or more, and they don't even come close to the amount of content that is included in this course. So kickstart your game development journey today and pick up the course right now, link in the description below. And with all that out of the way, let's get right into the video. So the first thing that we're going to do is go ahead and launch Unreal Engine 5.6. So make sure that you download the latest version of Unreal Engine. And you want to head over to the Games tab, and over here we have the brand new templates over here. So as you can see, we have the first person template, but you're not going to see the horror game template or the other different templates. So in order to actually create the project, you want to select the first person, and under the variant, you can see we have this new drop down to select the actual survival horror variant of the first person template. So we're going to go ahead and create that and name this to our horror game, and then we're just going to click create. Okay, so with the project loaded up, what you're going to notice right off the bat is if you hit play in this level, this is just the first person character. So this is actually just the blank first person template. So in order to actually open up the first person horror game template, under the content browser, we have this new folder called variant_horror. So for all of the new templates, it's going to have a brand new folder for the variant. So this, in this case, is the horror game variant. So if you double click open it up, you'll see it comes with a level_horror. So let's go ahead and double click to open and load that up. And this is the actual horror game template level. So you can see it comes with this sort of dark lighting and these little hallways. So I'm going to go ahead and hit play. And you can see we play with this simple first person character controller. We have a sprint bar, stamina bar at the very bottom. So when it runs out, you have to sort of walk. And it kind of gives us a very basic first person horror game controller. You can see we have some dark lighting over here as well. So let's go ahead and get started modifying this game so we can actually add an enemy AI that will chase us around. So the first thing you want to do is go ahead and go to the description of this video. I have some free project files that you can download. So we have these animations as well as this character that I got from Mixamo. So we want to go to our horror game and have this side by side. And in the variant horror, we're going to create a new folder and call this creature. And just double click open this up, because we want to import the animations as well as the model. So this skcreature.fbx, we're going to import this first because this is the character model. So drag and drop it into the content browser. And what you'll notice is we have this import content folder. So all you need to do is we're going to leave all the settings as the default. We're not going to actually click on any of the settings or modify it. We're just going to click the blue import button and go ahead and import the character. So with the character imported, it's going to import the character as well as these textures. So I'm going to create a new folder in here for materials. And I like to just take all the textures and materials, shift select all these, and just drag and click move here, just to keep things organized. Then we also imported this animation, this green animation sequence. So we can actually select that and delete it, force delete it. So we only have the skeletal mesh, the physics asset, and the skeleton. So just do a file, save all. Then let's go ahead and minimize this again, and let's put this side by side. Okay, then in the creature folder, we're going to right click and create a new folder for animations, and double click open that up. Then you want to select all of the animations other than the skcreature.fbx, and just drag and drop this into the folder. And then it's going to pop open with the import content. So for this, we're actually going to change some settings. So you need to scroll down till you see the skeleton section, and you want to hit the drop down and make sure that we select our skcreature skeleton, because it's asking us where do we want to import the animations onto, what character we want to import them onto. In our case, we want to import it onto that skeleton for our creature. And then we also want to click import only animations because we only want to import the animations. We don't want to import the animations as a separate character. So now that we have those two settings checked, we click import and it will only import the animations that we need. Okay, so now we can go ahead and just do a file save all, and now we have all the animations that we need. So next up, we'll need to create our animation blend space, which will allow us to blend some of these animations, like our crawling animation. So we have this running crawl. Basically, we want to blend this with sort of like an idle animation where, the creature is either standing still or just, prone completely. So we're going to right click and create what is called a blend space to blend the animation. So you want to go to animation, and under blend space, we're going to select that. So it's going to ask us to pick a skeleton. So in our case, we're going to select the SK creature skeleton and name this to our blend space underscore idle run. And then just double click and open this up. And we're going to dock this up at the top. So the blend space has a viewport in here. We can zoom in on the character. And at the very bottom, we have sort of this graph or this grid where we have two different values. We have a horizontal and a vertical value, which we can change over here under the asset details. So under the asset details, we have the axis settings, which controls this grid. We have the horizontal axis, so we expand that. We can go ahead and give this a name. So the name that we want to give this is for our speed, because we want to use the speed to determine what animation should be playing. Should we be playing the running animation or the idle based on the character's movement speed? So we have the speed, we have the maximum value and the minimum value. So for the maximum value, we're going to change this to 1,000. Then I'm going to change the grid divisions to 8, so we have more grid divisions over here. Then the last value I'm going to change is down under the weight speed for the sample smoothing. This controls how much smoothing between the two different animations should we have. We're just going to enter a value of 3. And this will just make sure that the animations, smooth transition from one to another. So go ahead and save that. Now we just need to drag in some animations to this graph. So under the asset browser, we can go ahead and do just that. So for our running crawl, we have this running crawl. We're going to shift and drag and drop it on the graph. And if you hold on shift, that will snap this animation to the graph. And also if you click on this little button over here, this will show the name of the animation. So we have the running crawl. We're going to place that at the middle bottom like so. So the speed value should be 500. Now we're going to need an idle animation because we don't really have, a idle pose animation. So in order to create that, we're actually going to duplicate one of these animations. So we have this running crawl animation. Let's just right click and duplicate this animation. And we're going to name this to just our idle crawl. Okay. And double click, open this up. So this idle crawl animation, all we're going to do to modify this is, let's go ahead and you can drag the timeline over here. And we're going to move it to right about like this point right here. And if you right click on the graph, you can see we can remove frames in range 6 to 14. So we're going to do that. And then now we have frames 0 to 5. So I'm going to move it all the way to 5 and then right click down here and do remove frames 0 to 5. So we should now just have a still animation frame. Okay, just like this. Okay, so if you hit play, it'll just loop back over and over. So that is our simple idle pose or animation. So if you save that, close out of there and go back to the idle run blend space, double click, open that up. We should now have that idle crawl animation or the pose. So we can shift select and drag that to 0, 0. And now you can see we can blend between the pose and the idle crawl run. So if you show these sample names, we have the idle crawl and then the running crawl. So if you hold down control will preview the animation. So if our speed value is 0, we'll play the idle. If our speed value changes up to 500 or more, it'll play the running crawl animation. Okay, so that is our simple blend space setup. Now we just need to set up the blend space with our character blueprint, which is what we're going to use an animation blueprint for. So close out of there, we're going to, in our animations folder, create a brand new asset, which is of the type animation blueprint. So the animation blueprint allows us to take things like a blend space and program in things like binding it to the character. So we can set the speed of our character and change the animation based on our character blueprint through this animation blueprint asset. So let's go ahead and select that. It's going to ask us to select a skeleton. So we're going to choose the same skeleton, the SK creature skeleton, click create, and then name this to ABP for anim blueprint underscore creature. Okay, and then let's double click and open this up. Okay, so in this animation blueprint, we have this output pose, which is the output animation that it should play. We're going to drag off of this result and drop it on the graph and search for the default slot. So the default slot node will allow us to play things like anim montages. So if we want to play a one-time animation, maybe like the monster is biting or hitting the character, we're going to do that through this default slot node. So that's what it allows us to do. Then off of the source, we're going to drag again, and we're going to add a state machine node. So we have the state machine node right over here. So the state machine node allows us to add in different states. So if we have a running state, a walking, a jumping state, crouching, we could add that all through this state machine node. So now that we have that, we can compile and save. It's going to give us this warning, but that's okay. So let's just double click and open up this node. So if you open up the state machine, you can see now we're inside of the state machine. So if you go back to the anim graph, this is the anim graph that we're just in. And if you double click, this is the state machine. So in here, we're going to add a new state. So off of this entry, we can drag off here, it creates this arrow. And if you drop it, we can add this new state. So add a state. We're going to add one for our idle and run state. And then let's double click this and open this up. And in the idle run state, we can go ahead and plug in an animation output pose for the result. So in our case, under this asset browser window, we have access to the animations. And in our case, we created this blend space. So let's go ahead and drag in the blend space onto the graph. And we have this blend space BS idle run node, which we can plug in the animation pose for the result. So now let's hit the compile button and save. And what you'll notice is it's now playing that idle animation from our blend space, our idle run. Okay, so now all we need to do is take this speed value, so this variable that we set up, we need to bind this to our character's movement speed. That way we can control what animation should be playing. So we're going to take the speed and drag and drop this on the graph and select this promote to variable. And now we'll go ahead and create a brand new float variable under the variables tab down here. So let's hit compile again, just so we can save those changes. And now we need to go ahead and bind this variable to our character's movement speed. So in order to do that, we'll head over to the event graph tab over here in the anim blueprint, and we're going to set up some simple blueprint logic to get our character's movement speed. So off of this, we have an event update animation that runs every frame, and a try get pawn owner, which will give us a reference to the owner of this animation blueprint. So off of this, we want to do a check, a is valid check over here, just to double check and make sure that the character is valid. And if it is valid, we'll go ahead and off of the try get pawn owner, get the velocity of the character. And then in order to convert this velocity into a float value, we want to take the velocity and do a vector length of that velocity. And that will return this green float variable, which we can hook up for the speed. So in order to set the speed variable, we just drag and drop it on the graph, and we select the set speed. We hook up the is valid for the execution, and for the speed variable, we just hook that up for the vector length. So now let's hit the compile and save. And now what we're doing is we're getting the pawn owner, getting the velocity, converting that to vector length, and setting that speed. So now we're getting the character's movement speed, which we can then use to determine what animation should we be playing in the idle run state. Okay, so all that is left to do now is to set up the character blueprint and set up our creature in it. So we can close out of the animation blueprint, and now we can go into our creature folder, and we're going to go ahead and create a new blueprint for our creature. Okay, so right in here, we're going to right click and create a new blueprint class up here. And in our case, we're going to pick a parent class. The parent class we're going to pick is the character class because it comes with some basic movement components and everything that we'll need for our enemy AI. So go ahead and select that, and it's going to ask us to name it. So we'll name this BP underscore creature. and then just double click and open up this blueprint. And I'm going to take this, dock this up at the top. So the first thing that's going to open is this viewport tab. So in the viewport, we'll need to set our character mesh because currently we don't have a character mesh. So over under the components, you can see we have a mesh component. So if we select the mesh component in the details, we can set the skeletal mesh asset. So for the skeletal mesh, we're going to hit the drop down and select that SK creature character mesh. And what you'll notice is it's floating in the middle. So we'll have to take this and move this down. Okay. And we also want to rotate this because you can see that this blue arrow, this is the front of the character. So we'll need to press E and rotate this 90 degrees, negative 90 degrees, just like so. So it's facing the proper direction. Okay, so compile that. And now we also want to set the animation blueprint because right now it's just in the T pose. So in order to set up the animations, you select the character mesh. In the details, we have a section for animation. And under the animation mode, we can just select use animation blueprint. And for the anim class, that will be the animation blueprint that we created. So in our case, the ABP underscore creature. So once we select that, you'll now notice that it's playing that animation blueprint, this idle pose. So compile and save. Okay. Now we can go ahead and actually drag this creature into the level. So if we were to go over here and drag in this BP creature over here, and if we were to hit play and run up to it, right now it's not going to do anything. Okay, we don't have any logic set up, but you can see we have our horror creature spawn into the level. So let's go ahead and actually set up the logic for this creature to chase the player around so that we can set up our basic horror game logic. So go back to the blueprint creature, and in order for this creature to have any sort of sense of its surroundings, we'll need to add what's called a pawn sensing component. So under the component section, we're going to click the add icon and search for the pawn sensing component over here. And this will add in this new sensing component that will allow our AI here to have things like sight and sound sensing so we can detect our player. So for the pawn sensing component, if you select that in the details, we have different settings that we can change, like the sight, how far it can see, how far it can hear, all of that stuff. So in our case, we're just going to bring the sight radius, which is this green half circle around the character. If we change this value down, you can see that we can scale it down, but this is basically how far the creature can see, its distance that it can see the player and detect it. So I'm going to set this to 1,000, and that will give it a decent amount of range. Okay, so just compile and save that. So now that we have the sensing component added, we can head over to the event graph where we can actually program in the blueprint logic for things like its detection of the player and also its simple, roam or walking or patrolling around the level. So in here, we're going to just delete all the nodes, compile that, and we're going to add some basic patrol logic so that the AI will just walk around in a simple path. Okay, so we're going to add a custom event in here. So add a custom event. And we're going to name this event to patrol. Okay, so compile. Every time you add in a custom event, you'll need to compile it immediately. That way it will add that event in. We're going to do a check. The first check that we need to do is, check and see if we are chasing the player. Because if we're chasing the player, we don't want to continue to patrol or walk around in a path. So we're going to add in under the variables a new variable by clicking this plus icon. And this will be named is chasing player ? And compile that. And this variable will be of this Boolean type, this red Boolean. And basically a Boolean is either a true or false statement. Okay, are we chasing the player, yes or no? So we're going to take this and get this on the graph and do a not Boolean off of it. And then we're going to hook up a branch. So if you right click and search for a branch, or if you press B and left click, you'll add in a branch node. Okay, so the branch will hook up for the condition if we're chasing, if we're not chasing the player. Okay, so if we're not chasing the player, then we can go ahead and do our patrol logic. So for the patrol logic, we're going to use the AI move to node, this AI move to, and that will move our character or our AI to a random point where we want it to walk to. So for the pawn, we need to drag off here and get a reference to ourself because we want to move ourself in this condition. And for the destination, we need to get a random point that's close to the AI. So we're going to use the get random reachable point in radius node. So the get random reachable point will just get a random point that's close to our player. So for the origin, we want to get our player, get our actor's location. Okay, for the origin, and then the radius will determine how big this, how far it should select a random point. So we're going to give this a radius of 300. Okay, and that will give us a random point to move to. Okay, acceptance radius, this is like how close it can get to that point if it's successful or if it fails. Okay, so we have the on success and on fail. So if it successfully reaches that point, it will call this execution. If it fails to reach that destination, it will call this execution. So what we'll need to hook up to the on success is a delay node, and also for the on fail, because just in case if that gets called, we want something to happen as well. For the duration, we're going to add some random float in range, just so we have, a random delay so that the creature pauses for a second or two. So under the minimum, we can give this a value of 0.5 seconds and a maximum value of 1.5 seconds. And you guys can play around with those, but I think those are fine. And then we want to go ahead and recall our patrol event. So I'm going to call our patrol. So this will give this AI a very simple logic that will move to a random point. It will pause for a couple of seconds, and then it will do the same exact thing, move to a random point again. So in order to call this event, we're going to call it off the event begin play. So search for the event begin play. This will get called when the game is started. Then we're going to call that patrol event. Now we'll go ahead and start this simple walk loop. We'll move to a random location and we'll do the same thing over and over and over. So hit compile and save. And in order for us to actually test this out, if we were to hit play, you'll notice that the AI isn't moving. That's because we need to add in a navigation mesh volume, so the AI can actually know where to walk around, where the paths will take it. So we need to, under the Q plus icon, search for a nav mesh bounds volume. And we're going to add in this nav mesh bounds volume, which is this simple box for the navigation. And we want to scale this up because it needs to be the size of the level. So we're going to go ahead and just scale this up, or we can input some values. So we'll do 100 by 100 by 100 in the details. And maybe that might be a little overkill. So we'll just do 50 all the way around. And now we can see if we go into the level, if you press the P key on your keyboard, you'll see that everything in green is where the AI can move to. So where the AI can navigate is highlighted in this green section. Okay, so you can see certain parts he won't be able to get up the stairs in this section because it looks like there's some issues there with the navigation, but everything highlighted in green is where the AI can move. So we press P again, that will hide that. So now if we go ahead and hit play, you'll see that the AI is randomly walking to a random spot. Okay, and it looks like it's choosing just random points to walk around. Maybe it's not too far, so you can definitely adjust the radius of how far it walks around. So if we go back to the blueprint, you can change things like the radius. So if you were to increase the radius value, it should be able to walk a little bit further. Okay, so it's walking much further than just 300 units. So now that we have a very simple patrol logic, we want to go ahead and set up the logic that will actually chase and detect the player if we're walking nearby this creature. So in order to do that, we want to head back over to the creature blueprint, and we want to add in our pawn sensing logic. So if you select the pawn sensing component, in the details we have this under the events, the on see pawn. So if the player is detected by this AI, it will have, we can add this event for, if it sees the character. So we're going to add a delegate right here, and then we'll add this event for if we see a pawn. So in our case, we want to just check and see if the pawn that we see is our character. So you can either do this by casting to the character to see if it's the character, or we can check and see if it has a tag. So I'm going to do actor has tag. I'm going to check and see if this actor has a tag of the type player. And off of here, we can do a branch. So you can press B or add in the branch node and hook that up for the condition. So if it is the player, then we can go ahead and chase the player. Okay, and so in order for this tag to actually work, we'll need to add this tag to our character. So the way that tags work is we'll need to go into our content folder, go to our variant horror blueprints, and we should have this BPFP horror character. So if we open this up, this is the horror game character. So under the class defaults, we're going to search for tags, and we should have an actor tag. So we can add in a new tag over here. You want to name this player the same exact spelling and punctuation as what we named and defined over here in this creature blueprint. Okay, so just set that, compile that, and now we can close out of that blueprint. So if it is the player, we can go ahead and do another check. So we want to add another branch. And for this condition, we want to check and see if we are chasing the player. So we already have this chasing Boolean. We're going to check that and double check and make sure that we are not Boolean. We're not currently chasing the player. Okay, if we're not chasing the player, then we can go ahead and set this is chasing player to now true, because now we are chasing the player. Okay, because if we are already chasing the player, we don't need to recall the same logic again and again. Okay, and then now what we want to do is save a reference to the character or the pawn that we're chasing. That way we know where they're at all times and we can chase them and move towards them. So I'm going to take this reference and drag and drop it on the graph and click the promote to variable, and we can rename this to our player ref for our player reference. Okay, so compile and save, and let's go ahead and hook up the execution just like that. And then now we need to call a chase player node or logic. So over here, down here, we're going to add a custom event, call this chase player, and let's compile and save that. And now after this, we're going to call that chase player node. Okay, so we can go ahead and start chasing the player. So for our chase player, this will actually be very similar to our AI move to logic up here. Basically, instead of moving to a random point, in our case, we're going to move towards the player. So we're going to first, we actually want to do a check, so add a branch. And for the check, we want to check and see if we are chasing the player. Okay, so if we are chasing the player, then we want to call the AI move to node over here. And for the pawn, that will be, again, our get reference to self, because we're moving ourself. And in our case, we're not going to use the destination, but we're going to use this target actor. So for the target actor, we can just plug in our player reference. We can get that and plug that in, and that will move our AI towards this target. Okay, now if we were successful in moving towards the player, we want to go ahead and call an attack so that we can attack the player and either deal some damage or make them lose the game. And if we failed in chasing the player, we want to go ahead and continue to either chase the player until we actually reach them and attack them again. So off of the fail, we're going to do a delay. Do a little delay here. And for the duration, we're going to do a random float in range. And for the range, we're going to do a value of 0.5 and a max value of 1.5, just like so. Okay, and then for the completed, we're just going to call the chase player node again. Okay, so it'll just re-loop itself. Now for our attack logic, if we were successful in chasing the player, in order to set up our attack, we're going to add in a custom event down here called attack player. So compile that. And now let's offer this success. If we're successful in chasing the player, then we'll call our attack player logic. Okay. So now in order to actually set up the attack, we're going to use some animations and a couple of other things, but let's just real quickly test out our chase player and detect player logic. So we set up the sensing component so that if we see the player, we'll go ahead and chase them, and we'll move our AI towards that player, and we'll loop back and do the same exact thing, or we'll attack them and whatnot. Okay, so we should be able to see the AI detect us and chase us. So let's go ahead and run over to the AI. So if it turns around, it now sees us, so it's going to run up to us and try and chase us as fast as we can. And you'll see that it stops because we don't have the attack logic set up. So it just kind of pauses there. So now let's go ahead and actually set up the attack logic. So over for the attack player logic, we basically want to go ahead and try and see if we're close enough to the player in order to call our attack logic. So we're going to do a sphere overlap actors node. What this does is it does a overlap to see if we are near the player. So for the sphere position, we want to get the actor location. Okay, get our location of our creature. For the radius, we can just do 100 units to see if we're close enough to the player to damage it. And then for the object types, we can make an array, and we only want to detect pawn or character object types. Okay. You can also additionally set a class filter, so we can only affect characters or blueprints of the type BP_FP_horror, which is that first-person horror blueprint, our character blueprint. Okay. Additionally, we can also add an actor to ignore, so we want to do a make array for this and just make sure that we ignore our reference to ourself. So drag up here and do a get reference to self. This way we just ignore ourself, we don't overlap ourself. Okay. So compile and save that. Okay, whether or not we're successful in overlapping and hitting something, we're going to do a branch off of that. Okay. If we were successful, then we'll go ahead and, attack the player, basically. So we're going to offer this out actors. This turns an array, so it's just a random list of players. But in our case, since there's only one player in the game, we're just going to get a copy of that player at index 0. And then we're going to go ahead and just do a couple of checks. Make sure that this is the character. I guess this isn't really necessary, but we can just do it. Get actor has tag. Just do actor has tag. Check and see if that is the player. And then we can do another branch and hook this up. Okay, if we really know that this is the player, then we can go ahead and call our lose logic. Okay. Also, we can play a couple of animations and stuff like that. But first, we want to go ahead and basically do like a player death event, so that the player has lost the game because the AI has reached the player and we've detected them. So in order to do that, we're going to set up some logic in the character to freeze our character from moving. So let's go into our BPFP horror character over here. And in the event graph, we have the things like the sprint logic, the possess logic, all of that. We're just going to go somewhere where we can add our own logic. So maybe down here, we can right click and on here, add a custom event and call this lose logic. So for the lose logic, we're going to basically freeze our character, stop them from moving and prevent them from moving anywhere. So we're going to get our character movement component and do a stop movement immediately. Hook this up. And then we're going to also disable our movement so that the player can no longer move around. Okay. So compile and save that. And now in order to call this lose logic, we can go back to our BP creature. So once we go ahead and detect the player, we get a reference to them. Off of this reference, we can call that logic, but first we need to cast to the character. So you could either cast to the character or you could set up a blueprint interface. For the sake of this tutorial, we're just going to use casting. So we're going to cast to BP_FP_horror game character and hook that up for the true. And now we have a reference to that character, so we can call that event lose logic that we set up. Okay, so that will go ahead and call this node over here, which will stop the character movement and disable the character from moving. So let's just compile and save this. And now let's just go ahead and test this out. So if I hit play, let's run up the creature, let's let it hit us, and now you can see we're frozen, we can't move anymore. And basically, we can still look around, but as you can see, it's pinning us down and we can't move our character. So also we want to freeze our character from moving the camera so we can play sort of like this death animation. So in order to freeze our character and stop them from moving the camera around, in order to do this, we're going to go ahead and in our BPFP horror, this is actually a child blueprint, meaning that this has a parent class. So on the top right, you can see this has a parent, which is the BP first person character, the default character template. Okay, so if we browse to this, click the browse icon, it will show us the blueprint that's the parent, which is the first person character blueprint. So if we open up this character blueprint, you can see that this is the blueprint that actually has all the logic for things like our camera inputs, our movement, and our jump. So this is the child blueprint, the FP Horror, that has the sprint, the spotlight, the camera, the flashlight, all of that is in here, but the parent blueprint has all the movement and input. So in order for us to stop the character from moving and stop them from looking around using the camera, for this camera input, we're going to modify this logic. So we're just going to add in the variables, add a new variable, and call this disable camera movement, ? Okay, compile and save, and make sure that this is in the BP first person character. And then for our look and our mouse look over here, we're going to move this over. Just grab these and move these over because we're going to add that branch. So add a branch in here. And for this, for the condition, we want to hook up our disable camera movement. Okay, if this is true, then we won't do anything. If this is false, we'll go ahead and aim like we normally do. And the same exact thing over here. Let's unhook this and add a branch. Okay, for the condition, we're going to hook up our disable camera movement. And for the false, we'll hook this up to the aim. So now we have this Boolean that controls whether or not we can look around with our camera. So if we compile and save that, now we can go into the child blueprint. So if we close out of this and go into the BPFP Horror, over on our lose logic, we should be able to set that Boolean set disable camera movement. We can set that to true. Okay, so hook that up and compile and save that. So now if we go ahead and hit play, if the AI goes and chases us and grabs us, now we can't move our camera. We're completely frozen. And so now we can do all the death logic, like play an animation and all that stuff. Okay, so let's go back to our BPFP Horror. And in order to play that animation, what we're going to do is, we're actually going to go back to our creature blueprint. And over here, we're going to, off of this horror, we're going to get the character mesh. Get character mesh. So character get mesh. And we're going to attach this creature to the character. So it's a little bit weird what we're doing, but basically we want to attach the creature to the character. That way we can play a little attack animation, sort of like a jump scare. So we're going to call the node attach actor to component. So we have this attach actor to component. And so select that and hook up the execution. For the target, this will be ourself. We want to attach the creature to the parent, which is the character's mesh. Okay, so we're attaching this actor, this creature actor, to this mesh component. So for the socket, we'll need to add in a socket. So in order to add a socket, we'll need to add it for the character mesh. So if you go to the FP Horror, the viewport, and select the mesh, the character mesh, we can browse to that skeletal mesh asset. So it's in the characters, mannequins, meshes, and we want to open up this skeleton. So this SK mannequin. Okay, so in the SK mannequin, we're going to select this root over here. And we're going to add a socket and rename this to the monster socket. And for this socket position, if we go ahead and select this, you can see that right now if we press W, it's right here in the center. So we're actually going to move this in front of the character and then also press E and rotate this -90 degrees so that the red arrow is facing the character like so. Okay, so save that. And now we're going to use this monster socket. So copy the name here, close out of there, and head back over to the creature blueprint and paste in that for the socket name. Okay, so it'll attach it to that socket. And then we also want to use the snap to target for the location, rotation, and scale. So that will go ahead and attach the monster to our character. And now we just want to play a simple attack animation. So in our folder over here, we want to go to our variant horror creature folder, animations. We have sort of like the zombie attack animation. So you double click, open it up. We have this sort of attack animation. So we want to create a montage of this in order to play this animation sequence on our character. So you just right click and we need to select the create anim montage. And that will allow us to play this animation onto our character, animation blueprint. Let's do a file, save all. We also want this animation to be looping. So if you double click this animation montage asset, in order to loop this asset so it plays over and over, you want to head over to the montage sections over here. Okay, there should be a window for that. And this little checkbox, all you have to do is click this and click default. And now you should have this loop icon so we know that this animation will loop over and over. So go ahead and save that. So close out of there. Now let's head back to our creature blueprint. And in the event graph, after this attach actor to component, we're going to call the play montage animation montage node. Okay, so it's going to ask us where we want to play this montage onto. We want to play it onto our character mesh. So grab that and plug that in. And for the montage to play, we're going to hit the drop down and select that zombie attack montage. Okay, so let's go ahead and compile and save this. And now let's go ahead and actually test this to see this in action. So now the creature should chase the player, attack it, make them freeze with the new freezing logic, attach ourselves to the character, and play this attack montage. So let's go ahead and hit play. Let's go ahead and attack us. So it's sort of like this jump scare. So he grabs us and we have this attack that's just looping over and over. So if we go ahead and play this again, say we're running away from the creature, and he just pops up and attacks us. Okay, so it's sort of like this jump scare logic, and the character can't move, just like that. So that is our very simple attack player logic. Now we need to also set up the logic whether or not it was unsuccessful in attacking. So in our case, if we allowed the creature to get close enough to attack, but it failed to hit us, we want to set up all that logic. Otherwise, the character or the creature will just freeze and won't do anything. So we're going to, off of this false, do a delay. And also off of this false, we want to do another delay, just like that. And we want to do a random float in range. So just give us a random value of 0.5 and a maximum value of 1.5, just like so. And then also we want to give this a chance, give the player the chance of being able to escape from the monster. So in order to do this, we want to give sort of the monster the ability to lose interest in the player that it's chasing. So we're going to do a branch, and we'll do a random Boolean with weight. So this sort of does a random Boolean, and this gives us a 50-50 chance of true or false. So it will either continue to chase the player, so we'll call the chase player for the true, or we'll lose interest. So we want to set the chasing player to false and just call our patrol logic. Okay, so it'll lose interest. So this is our reset logic. Okay, so if it fails to attack and kill the player, it will go ahead and either chase the player, continue to chase it, or it has a chance of going back to its original patrol logic. So if we hit play here, let's go ahead and let this guy chase us, let him get close. So you can see we can add in, make it a little bit easier for the player to escape the attack, but we do have a little bit logic built in so that if the player escapes, the creature can be reset. So now all that's left to do is I want to add a little bit more logic for our character. So in our character blueprint over here, I want to set it so that the camera always faces the monster, because in some cases, if I'm looking down at the creature, if it attacks me, my camera's not exactly focused on the creature's face, so I just want to make it sort of like a jump scare. So in our BP horror, we can go ahead and reset our camera rotation. So in order to reset the camera rotation, you just get the player controller, and we can call the set control rotation node, and that will reset the rotation. So we can right click and split this, and for the rotation, we're going to right click and get the control rotation, get the current rotation of our camera, and then break that, break the rotator, and we're only going to plug in the X value and the Z values just so we can reset those two. Okay, so compile and save. So now if we're looking down at the floor, and if the monster were to attack us, okay, so let's go ahead and move it over here. It'll reset and snap our window up like that. Okay. Also, we want to add in a little camera shake effect so that it can be, a little bit more of a jump scare. So we're going to do a sequence over here. So we can add in, some camera shake and stuff into the level. So to add in some camera shake, you can call the play world camera shake node. And for the camera shake, we'll need to create an asset for that. So let's go to our, just our variant horror over here and create a new blueprint class. All classes, search for camera shake. And we should have this camera shake base class. So select that and rename this to camera shake. And double click, open this up. So in the details, here's where we're going to add in the camera shake. And so you want to click single instance over here. And for the root shake pattern, we're going to select the Perlin noise camera shake pattern. So expand this. This will give us some different values that we can play around with. So under the location amplitude, I left that to 1. Let's expand the X, Y, and Z. This will change, what angle should the camera rotate and all that stuff. So for this, I just did 50, 50, and 50. And for the rotation, under the pitch, yaw, and roll. So for the amplitude multiplier, I did 3. And for the pitch and yaw, I did 3 for the amplitude. Okay, so those are, I believe, all the settings that I did. So you can mess around with all these values, and this will change, how the camera shakes, how it rotates, which direction. But basically, we're going to select, in our horror character, select that camera shake, the one that we just created, and we can play that over there. So for the location, epicenter, we're going to get the actor location, and then we're just going to plug this execution like so. You can determine the radius, so we'll do 100 for the radius. The outer radius will also be 100, and let's just compile and just save that, okay? So now let's go ahead and test this out. Let's hit play. So we run up to the creature, should attack us, and now we have this weird camera shake. So it's sort of like a jump scare effect, as you can see. And the creature just, continues to attack us over and over, okay? So very simple, yet effective camera shake. So again, you guys can just play around with the values and see what works best for you. Okay, the last thing that we want to add is maybe we want to add a lose widget, a reset, so we can reset the level and, replay or retry. So let's go ahead and create that UI. So under the variant horror in the UI folder, you can go ahead and actually modify this UI horror widget. So we double click and open this up. We already have a widget over here. Okay, so in this UI horror widget, we can go ahead and add a lose screen. So over here we have this overlay. So on the overlay, we're going to search for, under the palette, another overlay and drag and drop it onto it. And select this overlay. We're going to set this to fill horizontally, fill vertically. And onto that, we're going to add a border. And select this overlay. First, let's actually select that and change this to a variable and rename this to our death screen. Okay, so it's our death screen overlay. So onto that, we have this border. So select the border and fill this. And for the brush, we're going to expand this. And under the tint, we're going to change this to a dark color and maybe alpha of 0.5 or something like that. Okay, so it's a little transparent. So compile and save that. Okay, now onto that border, we're going to add a vertical box. Search for vertical box and drag and drop it. And select that vertical box and let's center this in the middle. And into that vertical box, let's add some text. So we're going to add some text into there. Let's select that text and we'll name this to "You Died." Okay, and so for the text, for the font, we can expand this and scale this up. Okay, like that. And then let's add a horizontal box into this vertical box. So it should be right below that. And in there, we can add some buttons. So add a button into the horizontal box. Okay, should be inside of it. And onto that button, let's add some text. So we have some text, so we'll drag and drop it onto the button. And over here we can rename this to quit. So we have our quit button. Select this button, let's make this set to fill. And let's copy and paste this button again. So we have two buttons. So select the first one, let's set the padding of, maybe 10 padding. So select both of the buttons and give it padding of 10. And then this button over here, if we select that text, we can rename this to retry. Okay, so we have a quit and a retry button. Let's actually change the button style. So if you select the button itself, under the style, you can expand that, and under the normal, we can change the tint, and that will change the color of the button. So we change this sort of to this dark gray. That will change the style, so you can copy and paste the style. So let's copy the style. Let's go over to this button over here and paste that style, and that will copy the same button style over. So compile and save. Now let's just set up the buttons themselves. So these buttons, we have the quit button. So select this, rename this to quit button. And this other one is the retry button. So select that and rename this to retry button. Okay, so compile and save that. All right. So now all we have to do is select this death screen, and by default, this should be hidden, because if we were to hit play right now, we're going to see that you died immediately. So we want to go ahead and select this death screen, and under the details, under visibility, we want to set this to hidden by default, and we can also toggle the visibility in this widget like so. Okay, so compile and save that. And now in the graph, I'm going to head over to the graph, and we'll add a event to toggle this on and off. So if we get the death screen over here, we can add in a custom event, call this, show lose widget. And then all we have to do is set the visibility of this death screen to visible. Okay, so compile and save. So now in order to actually show this, if we go ahead and hit play here, you see it's not currently visible. In order to show this, we need to go to our first person horror character, and right over here, once we go ahead and play our camera world shake, we have the sequence. So off of this then 1, we can add a delay. I'm just going to add a delay of 2.5 seconds. That way we can see the creature attack animation before we show the death screen. So we want to get our UI horror. This is a reference to our widget, that we have, and then we can call that show lose widget inside of it. So let's hook this up like so. Compile and save. So now it should show it if we die. So if we hit play, we run up to the creature, okay, and it attacks us, and now it should show you died. We have the quit and retry. Right, currently we can't actually click on the buttons. We can't see our mouse. So in order to show our mouse cursor and allow us to click on the buttons, we need to go back to our character over here, and we need to enable UI input and also show our mouse cursor. So you want to right click and get the player controller. Okay, and then we can call the set input mode. We want to set it to game and UI. Okay, so select that. And also we want to show the mouse cursor. So off of this, we want to do a set show mouse cursor and set this to true. Okay, so compile and save. And now in order to set up the actual buttons, we want to go to our UI horror over here. And if we show the death screen, we can select the buttons and add on clicks. Or we can head over to the graph and select the buttons over here. We have a quit button, add a on click. Also our retry button, we can add a on click. So for the quit button, we'll just, quit game, call the quit game node. I'll just close the game. And for the retry button, we can just reopen the level. So we want to get level name, get the current level name that we're in, and then we're just going to do a open level by name. And for the name, we'll just plug in our current level name, and that will just reset the level. Okay, it'll reopen the world. So compile and save. And in order for this to actually work, we want to go ahead and reset also our input. So you want to right click, get controller, get our player controller, and we need to set input game only. Just reset our input. Let's flush our input and also show mouse cursor. We want to set that to false so we hide the cursor. Okay, so compile and save. And now if we hit play, we go ahead and have the creature attack us and kill us. Okay, and it should show our death screen. So now we have our buttons over here. So I click quit, that will quit the game. If I go ahead and die again, we should have the retry. So I click retry, it'll reopen the level. Okay, so we can continue playing again. So that is pretty much our simple horror game mechanics. As you can see, we have a simple creature that will actually chase the player, and we can run away from the creature. If it attacks us and finds us, we have sort of this jump scare, and we have the you died. You can quit the game or retry, respawn in. And of course, if you wanted to, you could add in multiple different types of creatures that attack the player. And also you could add more different types of mechanics. So maybe you could add in certain abilities for the player to escape from the enemy and also be able to hide. So yeah, that's pretty much it for this tutorial. So we covered over how to create our own horror game using the brand new horror game template inside of Unreal Engine 5.6. So if you guys enjoyed this video and you actually learned something from it, make sure you leave a like and actually comment down below what type of future tutorials or videos you'd like to see on the channel. I've already made a brand new tutorial on how to modify things like the first-person shooter game template. So go ahead and check that one out, link in the description below. And also if you guys want to learn how to make your own complete multiplayer survival game from complete scratch, check out my course right now, as it goes over more in depth how to create a game from scratch. I show you things like how to actually set up the gameplay for multiplayer as well as single player, how to set up listen servers, dedicated servers, so many different gameplay mechanics like different items, inventory systems, and so much more. So if you really want to learn game development, this is definitely the best course for a reasonable price compared to a lot of other Unreal Engine courses that cost, upwards of almost $1,000. So definitely check it out, link in the description below. And that's pretty much it for this video. So hope you guys enjoyed, and I'll see you guys in the next one.
Have you ever wanted to make a multiplayer survival game? Well, now you can. I just released my Unreal Engine 5 multiplayer Steam survival game course, where I show you how to make a complete survival game from start to finish. In this course, you will learn how to make things like a drag and drop inventory system, a complete crafting system where you can craft all sorts of different items, a harvesting system where you can chop down any tree, rock, or bush that you see on the map. We create 9 unique weapons and tools, things like a rocket launcher, pickaxe, hatchet, rifle, bow, and so much more. We create an entire building system where you can build your own bases using foundations, walls, ceilings, and you can upgrade your base from wood to then stone and then to metal. We add a raiding system where you can attack other players and raid their bases for loot. Then we create this open world map that has different biomes, procedural foliage, and each tree, rock, or bush that you see on this map can be harvested for resources. We add things like procedural AI, like this deer that you can hunt and harvest for resources. We also create these interactable structures, things like this refining forge where you can smelt iron ore. We have a crafting bench, storage box, and so much more. There is a complete social system with player chat, voice chat, and it's all put together using these Steam sessions. I show you how to package and ship the game, build the dedicated server, and host it on an external hosting site such as Amazon Web Services. This course was designed with beginners in mind, so if you are new to game development or Unreal Engine, you can take this entire course. I walk you through step by step, and I explain the why behind what we are doing through each lecture. The course starts out by showing you how to install the Epic Games Launcher, get Unreal Engine installed, all of the basic UI, input, etc. The course is formatted in a way that you start out as a beginner, and throughout the course you build intermediate skills, and then towards the end of the course we go into more advanced topics. So no matter if you are a beginner, intermediate user of Unreal Engine, or advanced user, you'll be able to follow this course and learn lots of new things. All of the project files for this course are included, so you don't have to worry about purchasing any other additional marketplace assets. All of the lectures are recorded in 1080p with high quality audio. I am the instructor for the entire course, and if you want a sample of my lecturing skills, you can check out some of my popular tutorials here on my channel that many people have praised for explaining concepts clearly, effectively, and with simplicity. This course teaches you how to make so many different gameplay systems that you won't find in any other Unreal Engine 5 course online. In fact, most Unreal Engine 5 game development courses you'll find online only show you how to make a basic game with maybe 1 or 2 different mechanics. They don't even scratch the surface to show off what Unreal Engine 5 is capable of. Not to mention, these courses charge a premium price tag. And the problem with these basic courses is that they show you only how to make a demo, that once you add more than 10 mechanics, they break down and become performance disasters due to either the lack of scalability or poor game design. In the ultimate Unreal Engine 5 multiplayer first-person survival game course, I will not only teach you the proper way of designing the framework for your game, but also walk you through adding more custom items, weapons that will scale properly without heavily affecting your game's performance. This course is currently in early access, but if you enroll today, you'll get a big early access discount. The price of this course will be raised later on, but if you enroll now, you'll get access to the entire course and all future lectures that will be added. With that being said, new lectures are being added every single week, and once you enroll in the course, you get access to the private Discord server community. So take your game development skills to the next level by enrolling in this course. The link will be in the description below, or you can head over to smartpoly.teachable.com to check out the course. So with that being said, hope to see you guys there.